All right, welcome back everyone. In today's explainer, we're diving into a mathematical investigation to uncover the hidden rules that secretly govern every number in the universe. We're looking closely at prime and composite numbers. Now, you might think numbers are just, well, numbers, but there's actually a massive silent divide in the mathematical world, and today we're going to investigate exactly how to crack that code.
So have you ever actually stopped to wonder why some numbers have just a few factors, while others are literally packed with them? It's like, why are some numbers bursting with these hidden mathematical clues, while others are basically empty? That's exactly the mystery we're going to solve together today.
Here's our roadmap for the investigation. We'll start by unlocking factors, identify the prime suspects, check out the composite gang, look at the ultimate rule breaker, go hunting for primes, and wrap up with a final quiz. Let's get right into it.
Section 1. Unlocking factors, the hidden clues inside numbers.
Okay, to kick things off properly, we really need to define our fundamental building blocks. What is a factor? Well, a factor is simply a number that divides another number exactly, without leaving a remainder. So think of it like a perfect building block that fits into our suspect number flawlessly, with zero leftovers. Keep that in the back of your mind, because identifying these blocks is literally how we classify every number out there.
Moving to Section 2, the prime suspects, the exclusive two-factor club.
Let's check out our first set of numeric suspects and see what kind of patterns pop up. Take the number 2. It only has the factors 1 and 2. And then look at the number 11. It only has 1 and 11. What's super interesting here is that these numbers share a really strict, highly exclusive pattern. They only ever have exactly 2 factors. Absolutely nothing else divides cleanly into them.
We call this exclusive little faction the prime numbers. By definition, prime numbers are numbers that have exactly 2 factors, 1 and themselves. If you look at examples like 2, 3, 5, 7, and 11, they're strictly bound by this 2-factor rule. They're incredibly solitary numbers, locked down tightly with just those 2 clues.
All right, Section 3, the composite gang, which is a much more crowded club.
Let's pivot for a second to a totally different set of numbers with, well, much messier and far more crowded habits. Look at the number 4. It has the factors 1, 2, and 4. And number 10? It's got 1, 2, 5, and 10. This perfectly illustrates just how crowded these numbers are with clues. They completely break that prime rule by happily taking on 3, 4, or even more factors.
And that brings us right to our next category, which are composite numbers. These are simply numbers that have more than 2 factors. So, numbers like 4, 6, 8, 9, and 10 all belong to this crowded club. They're made up of multiple intersecting building blocks, which is exactly why we call them composite.
Next up, Section 4, the rule breaker. Let's talk about the anomaly of number 1.
Now, we actually need to hit pause on our investigation for a second here, because we've stumbled onto a massive anomaly. Let's put the number 1 right under the microscope. Think about its factors for a second. What divides exactly into 1 without a remainder? Well, just 1. The number 1 is the ultimate lone wolf because it only has one single factor, exactly itself.
So, where does it fit in all this? Well, because it totally refuses to have exactly 2 factors, it's not a prime number. And because it doesn't have more than 2 factors, it's absolutely not a composite number either. The number 1 is neither. It is our ultimate rule breaker. You definitely want to remember this vital fact when you're profiling numbers.
All right, Section 5, hunting for primes. Let's track some suspects in the wild.
Let's get out there and actively track down some suspects. If we methodically check each number up to 20, they become pretty easy to classify. For instance, we find primes like 19, which only has factors 1 and 19. But then, look right next door at its neighbor, 18. 18 has the factors 1, 2, 3, 6, 9, and 18. It's a huge contrast. You have a pure prime sitting right next to a highly composite number. If we extend our dragnet a bit further, looking between 21 and 50, we successfully isolate these 7 specific numbers: 23, 29, 31, 37, 41, 43, and 47. Every single one of these possesses exactly 2 factors. They are the elusive primes, just kind of hiding out in the mid-double digits. Now, right before we jump into our final challenge, I really want you to memorize this: the detective's quick trick. It's a cheat sheet to instantly profile any suspect number you come across. Step 1. Exactly 2 factors? It's prime.
Step 2, more than 2 factors, it's composite. Step 3, only 1 factor, it's neither. Make sure you lock those 3 rules right into your memory. And finally, Section 6, the final number quiz. Time to test your skills. Okay, it's time for a rapid-fire quiz. I actually encourage you to pause the explainer after each question to lock in your guess. So let's start with question 1. Is 13 a prime number or a composite number? Think back to our quick trick. Try to divide 13. Does it have any hidden clues, any perfectly dividing building blocks, other than 1 and 13?
Well, if you guessed prime, you are spot on. The number 13 only has exactly 2 factors, 1 and 13, which makes it a very proud, undeniable member of the exclusive Prime Club.
Moving right along, let's tackle a rapid double question. Question 2. How many factors does a prime number have? And question 3. Is 9 a prime or a composite number? Think about the absolute rule of primes for a second, and then put the number 9 under the microscope to see what its building blocks actually are.
Let's check those answers. For question 2, exactly. A prime number has exactly 2 factors, never more, never less. And for question 3, 9 is a composite number. Why? Well, because its factors are 1, 3, and 9. It's divisible by 3, which pushes it over that 2-factor limit, right into the composite gang.
All right, here we are at our final challenge, questions 4 and 5. I want you to write down any 3 prime numbers between 10 and 20. And then, tell me, is the number 1 prime, composite, or neither? Recall our lineup hunt from earlier for that first part, and then identify the status of our famous rule breaker for the second.
Excellent detective work confirming these. For question 4, your possible primes between 10 and 20 are 11, 13, 17, and 19. Any 3 of those is a solid win. And for question 5, as we know by now, the number 1 is neither prime nor composite. Honestly, you've officially mastered the basic profiling of numbers.
Bye students. Don't forget to subscribe for more fun math videos.